Well, now that I understand what CarboScen is basically about, could you explain some of the advanced features? Like, say, if we start with the little tab that says include uncertainties, what does that do?
Maybe better not to start with that, because that's the most complicated thing that you can if you want to compute uncertainty, but there are various ways to do that, and let's talk about that in the last clip.
All right. Well, what about the carbon densities at the start? There's two options where you can either choose the carbon densities to be the same as the equilibrium values or where they differ. So how does that work?
Yeah, so you have to choose one of these two. If I click here, the bottom one, there are two more rows that are added. So you can set start values which differ. So if you remember, let's go to the results. Now there is no impact on the results because even though there are these rows for differing carbon density values at start, but the set value is the same, 100 and 100. So if we look at the results, there's no change. We can see that biomass carbon density in the forest is 100 in the beginning as before. But now if I change this carbon density value at start, for example, into 50, this could be the case, for example, if these forests which are in the landscape are not yet old, but still all these forests, the old and these which are there in the beginning and the new forests, they all approach a carbon density equilibrium value of 100. You see that this beginning drops from 100 to 50.
Yeah.
That's what it does. But still they all approach this 100 value. So let's go back to the settings. So that was something you can choose here in the top left. If I go back to the carbon densities are the same in the beginning, I choose that. These two additional lines disappear again.
All right, that's pretty clear. Well, what about how do you choose between dynamic land use or linear land use?
Yeah, so dynamic in this case, maybe the word is not the best possible, but it's about land uses changing so that there's a fixed proportion of the land use of the previous land use that is changing. For example, in this case, it was 6% of the cropland every year converts into forest. So it approaches zero. If we would let this change to go on, it would approach zero. But if we change this into linear, let's see what happens. Without changing this 6% value, and we go to results, you see that there's 6% of the original cropland area that is converted into forest every year, and it goes into zero pretty fast because it's a much larger. Initially, it's the same land area that is afforested, but as it goes on, it goes into zero. And so maybe you are interested in knowing which one I would recommend, or
yes.
Yeah, it depends. Sometimes it's better to, well, depends what kind of land use changes are expected to happen in the landscape. In many cases, the default, the dynamic transition rate is a natural approach. In many cases, not all if the deforestation rate, for example, is fast in the beginning, it doesn't go on so that all forests disappear with that speed. But it's rather the transition rate goes down with time.
All right. Well, what about on the right? There's a button saying load.
Yeah, that's when I click that, I can load a file, a setting file. Instead of entering the values into this graphical user interface, I can load a setting file and automatically directs the CarboScen directs into the bin under the CarboScen folder. But there are no files to use at this point, because this is you haven't created any files, so then there's nothing to load. But in case you would work with CarboScen and create some settings that you might want to use in the future, it's a good idea to save them. And that's why, and then later you can load them. That's why you have the save button here.
Okay, all right. And what about reset?
Reset is something that you can use if you just want to have a fresh start, and you can adjust the number of land use classes and have a new start.
All right. So far, there's only been 2 land use classes, forest and cropland. So what if I have some other type of land use class?
Yeah, so 2 is very little. So probably in more typical cases you might have 5 or 15 of them. So just click the plus there if you want to enter the land uses manually like this and not to use a ready file. And then you can add, for example, then you will add the name and all the other information that you want to use, and all the numeric settings as well. And automatically the land use change matrices will have the additional columns and additional rows, so that more changes are possible. Maybe we could do a simulation with pastures included. Would that be useful?
Yeah, that sounds very interesting.
Yeah, so we could have no pasture in the beginning, but we could have, let's say, some of the forest converted into a pasture. It could be, for example, 5 or 4%. Let's put 4% annually of the forest land. So let's see what happens then. We go to the results. So you see that there's cropland is decreasing, pasture is increasing from 0, and forest area is first increasing because there's so much afforested from cropland. But when forest area is getting higher, there is more deforestation again into pasture. So that's why it goes down, and after 2050 there's no change.
All right, that seems fairly straightforward.
Yeah.
What about there's a button named copy?
Yeah, that's right. So in the default there are these 2 land use change matrices, but if you want to add periods or time spans, you click copy, and now we have 3 of them, and you need to adjust the years. This could be, for example, the middle one could be now for until 2060, and the last one could be from 61 to 2100. Oops, There's a wrong number there. Okay, did you see it turned red because it didn't make sense? These time spans here didn't match the time span for the whole simulation.
Yeah, that seems like a handy thing.
And now, because all these are zeros, there's nothing interesting, even though we added one land use change matrix, but there's nothing new in these pictures. But we can do something. For example, in the middle one, we can, if we have very rapid deforestation in the middle one, back into cropland. So 10% of forest area converted. Sorry, that's in the wrong cell. It should be in this one. So 10% of forest area converted into cropland every year during this middle period in the 50s, or 51 to 60. And then we go to the results. We will see that this 10-year period with the rapid deforestation is seen here. The red one goes down and the orange one for cropland goes up. And we start to have some interesting patterns for total carbon density.
All right, well, what about the export in the upper right-hand corner?
Yeah, that's like the name suggests. You can export the results. Of course, you should have a file name that is meaningful for you, and you can save your data somewhere, these results, and then you can create graphs which are better match your present requirements of your presentations or publications and so on.
All right, I see.